So I am going to now hand it over to Alex.
Yeah, thank you. First of all, thank you, organizer, for inviting me. And I'm Alex Zhukovich, an Android developer at dataway.com. We, as many other companies, use Android architecture components. So today I want to talk about them, about how they work internally, because if you know internal work, you can optimize performance of your application. You can just use the API in more smarter way. So the foremost popular architecture component is Lifecycle, LiveData, ViewModel, and Room library. So I want to concentrate on internal work of such components because they do all essential work which most of Android application needed. So let's start with Lifecycle. Lifecycle is super important component for any Android application because almost any visual part of the screen, it can be activity or fragment or even service, has own lifecycle, and of course Android application also have one. So let's start with pretty familiar situation, I think, for everyone. When our screen is on foreground, we want to start doing some jobs. When we move to another screen or close our application, we want to stop doing some jobs, some of them. In addition to it, we can have situations when we want to close and avoid some memory leaks before our activity or fragment will be destroyed. So as you can see in this approach, we should write a lot of boilerplate code, and we have a bit better way. We can use lifecycle observers and create something like small component. In this example, I propose to create a logger, and inside this logger, we can put our lifecycle. So it will be lifecycle of our activity. And what is great about lifecycle observers is that we can automatically remove this observer from lifecycle owner. In our case, it's activity. Also in this component, we can use on lifecycle events, and it helps us to handle all changes in lifecycle of our lifecycle owner. So the whole lifecycle framework is built on 3 build components. It's lifecycle owner, and lifecycle observers. Speaking about lifecycle owner, during this talk, we will talk about 3 of them. It's app-compat activity, lifecycle service, and a fragment. Many other lifecycle owner based on fragment. So if you know how fragment work inside, it will be pretty obvious. And let's come back to lifecycle. So lifecycle has 3 base methods. It's add observer, remove observer, and get state. And to announce event and state. So if we combine this announce, it can be easily mapped to the lifecycle of any activity or fragment. So, and when we talk about add and remove observer, this method allows to add observer to lifecycle owner as example to the activity. And here I want to start with app-compat activity as an entry point for many applications, because it's still an Android application and it needs an entry point, and it means that all entry points are activity. So app-compat activity extends fragment activity, and fragment activity extends component activity. When component activity is created, inside it we also initialize a report fragment. So report fragment is needed for dispatching all events to lifecycle registry. Lifecycle registry can handle everything and notify our observers, which is placed in observer list of our lifecycle owner. In this case, it's app-compat activity. So the next lifecycle owner is a fragment, and with fragment it's working a bit differently because we have methods like perform, start, stop, resume, etc. And in addition to it, for dispatching events to lifecycle registry, we have methods like handle lifecycle event with event, which can be passed as a parameter to this function. And the next one is lifecycle service. So this service is built on top of traditional service, and it has access to a service lifecycle dispatcher. And service lifecycle dispatcher interacts with lifecycle registry, and lifecycle registry, as usual, handle all state and can notify subscribed observers. And one really interesting component is process lifecycle owner. It's something like a lifecycle of the process of our application or of the whole application. So if we want to use it, we need to add two dependencies. It's lifecycle extension and lifecycle compiler. During compilation, process lifecycle owner file will be generated and added to Android manifest. And this initializer has access to a lifecycle dispatcher and process lifecycle owner. They communicate with report fragment, and report fragment communicate with lifecycle registry. However, here we have one small trick. All events delayed by 700 milliseconds, and this delay is needed to be sure that activity moved to the background. Because if we take a look at two different situations, and in the first situation, we just have activity on the foreground and just close our application and move to the home screen of our launcher. And in this case, onStop event will be called and dispatched. In case when we from activity A move to activity B, onStop event also will be dispatched. And in this case, inside lifecycle registry, the framework is checking if any other activity was opened. If no activity wasn't opened during 700 milliseconds, it means that our activity really moved to the background. So let's move to the LiveData. I think it's right now extremely popular Android architecture component. And LiveData is a lifecycle aware observable data holder class, which we usually use near interaction with user interface. So we should remember that we can observe or get data from the LiveData using observe forever, or get value method. And we should remember that our observe method is lifecycle aware, because we put lifecycle owner inside this method. So I want to take a look at how we add and remove subscription to LiveData object, and what is happening when we change any data. So when we use observe method, the first parameter is lifecycle owner and other is our observer. First of all, we check that our lifecycle owner is not destroyed. After it, we check that our observer is unique in the context of owner. It means that the similar observer cannot be added to two fully different lifecycle owners. And before our lifecycle owner will be destroyed, we automatically remove our subscription. So, and right now, super important difference between set value and post value method. It's always was described in documentation, but I saw that many people don't really think about these two methods, because set value method should be called from the main thread and post value from the worker thread. When we take a look at internal implementation of set value method, first of all, we check that this method is called on the main thread. After it, we increment version of the data, because we can have multiple lifecycle owner can have a possibility and want to observe data from the same LiveData object. And it means that we want to send this information to all observers. And for it, we need data versioning. And final step is, of course, set value inside LiveData and notify all observers. And more interesting situation we have with post value, because from post value, first of all, we post data from any thread to the main thread, and later on check that we are on the main thread, increment data version, update value, and notify all observers. Unfortunately, I saw that a lot of people always use post value method, and it means that you lose some time because you change your thread from main to the main. In addition to it, you have additional verifications that we are on the main thread. So it means that we just lose our time. And the last interesting part of LiveData is get value method. If you take a look, it's nullable type. It means that if we have data inside LiveData, it's return it. Otherwise, it just return null. I wanted to show it because unfortunately, a lot of people just expect that getValue method always return any data. And if you check internal implementation, you can see that very often it can return null, especially if it's nullable type. The next part is ViewModel. So we as Android developers very often face with situation when we should handle state of our application, and our application and our screens should survive configuration changes. During Android history, we had different approaches to do it, and the latest solution is ViewModel. However, I want to start from take a look at all solutions which we have in Android development, which many developers used, and take a look at ViewModel and check if ViewModel is something fully new or it's based internally on some other approach. I think for all developers who work with Android more than a few years, as minimum once at their life had idea try to use config changes, a property from Android manifest. So this property just block configuration changes. However, we can handle it manually. The most important part here is that we should really rewrite big part of Android framework, especially that part which connected with working with resources. Because in Android, we can create layout for landscape and portrait. And of course, if we will use this property, we cannot use this change, and we should change a lot of stuff manually. In addition to it, everything connected with translation and different languages. So if you want to use it, you should write a lot of functionality for working with resources, and it will be super complicated to do it without any issues. The next approach, which was used pretty often previously, is on retain non-configuration instance and get last non-configuration instance. So in any activity, we have an agreement that on retain non-configuration instance will be executed between onStop and onDestroy method. It means that inside this method, we can cache any data, and when our activity will be recreated, we can get this data. Many developers try to use it in the following way: just to cache whole activity object, and after recreation, we have current activity object and previous one. Of course, the whole activity object is something pretty big, but it was possible. And if in your previous activity object you already had some calculated data, you can just get this data and use it. And the next approach appeared together with fragments. So usually when fragment attached to the activity and your activity will be recreated, fragment also will be destroyed. However, we have possibility to create retained fragment. And retained fragment will survive configuration changes. However, we should also remember about few parts, and we should do a lot of manual work. First of all, we should attach and detach this fragment in a proper time. After it, we should create communication protocol. In this case, it's called callback. Communication protocol between activity and or fragment and retained fragment. If we have many retained fragments, we should create many such protocol for different cases. And as you can see in this case, we have a lot of manual work. So let's take a look at current solution at ViewModel. So with ViewModel, we shouldn't write a lot of boilerplate code because our class should be based on ViewModel or Android ViewModel if we need a context. Later on, inside activity or fragment, we should initialize it with ViewModel provider, and we can start using it. So it's much simpler than all previous solutions. Let's take a look what we have inside a ViewModel provider. So first of all, constructor of ViewModel provider require a ViewModel store, and later on we can get our ViewModel object. So we should take a look at two different situations. When we first time launch our activity, and we should create our ViewModel. In this case, we will use Android ViewModel factory. And this factory will initialize a ViewModel or Android ViewModel object, and later on will cache it inside ViewModel store. And of course, it will be returned to our activity. When our activity was in background and we come back to our application and we have any data inside ViewModel store, we can just get this data, and our existing ViewModel wouldn't be created from scratch again. And here it's very important that inside component activity we have get ViewModel store method, and in this method we just use get last non-configuration instance object. So as you can see here, we have our old friends, which was used some time ago. Of course, this solution is modified, but it's also based on some existing in Android for many years solutions. And let's take a look at whole pictures which we have for component activity with caching and restoring data of our ViewModel store. So first of all, between onStop and onDestroy, onRetain non-configuration instance is called. And inside this object, we cache all our fragments and all our ViewModels and our ViewModel store. And later on, when our activity will be recreated, we have access to get last non-configuration instance and can get our ViewModel store from this method. So as you can see, we don't have a lot of magic inside. It's based on already existing solutions, which was used for quite some time previously in different form with additional complications. And right now we have ViewModels, but internally it's used pretty similar way of doing job. However, I checked how it's worked around a year ago. And the main difference is that under the hood, it was used retain fragments. So during last year, internal implementation is changing. And it's also very important because previously we used ViewModel providers, and right now it's ViewModel provider. So it also was implemented inside component activity, but implementation was changed, and final result for the final developers who work with API looks more or less similar. So the last part of this talk and last architecture component, it's Room. And very important to understand that Room, it's not specific database. Room, it's a wrapper over SQLite. And SQLite installed on every device. So let's take a look on the way how it's installed on every device, and maybe we have specific version of SQLite on different devices. And unfortunately, or fortunately, yes, based on device, we have based of Android API, mostly we have different version of SQLite. In addition to it, we can have different version of SQLite based on vendors, because different vendor can also choose different SQLite database version, which will be installed on device. And very important to remember that in some versions of SQLite was fixed some issues which appeared in previous version. And it's also something to remember that when you use some complex stuff and maybe some complex query, it's always good to check on different versions, because theoretically it can work a bit different, but practically almost always it's work good enough for all applications. So let's try to create super simple database with one table, and let's check how Room library work inside. So first of all, we need to create table representation, and in this case we need entity annotation, and we should create our class. And each entity should have one primary key, and it's super important because a lot of internal work based on primary key. Later on, we need a way how we can interact with our table, and for it we need data access object. In practice, it's interface with our annotations and methods and annotations like query, insert, update, delete inside this interface. And the last part is to create an abstract class with database annotation And inside this annotation, we should, inside this abstract class, we should also have access to all our data access objects. And during compilation, for each data access object will be generated a new class, and this class will have underscore impl postfix. So let's take a look at basic operation and try to understand how it really works inside. So first of all, let's take a look at insert operation, and for it we have insert employee function. And this insert employee function, it's part of our interface, which we saw on the previous screen. And here we can see that everything inserted inside transaction. And in addition to it, we use insertion adapter of employee. So this adapter is created inside constructor. And inside this adapter, we override framework overrides to functions. It's create query and bind. So bind, it's needed for mapping between our entity and support SQLite statement. And create query is needed for creating query. And as you can see, it's usual SQL query. And all question marks later on will be replaced with mapped data, which we have inside bind method. The next part is update operation, and for update and delete we use different adapter. And inside this adapter, in where section, we verify our ID. And our ID is our primary key. So it shouldn't be ID, it always will be primary key. Everything also inserted into one transaction. And the main and the most interesting part is delete query, because with delete query, we verify only primary key. So if we imagine that we create our entity object manually, which will be fully different from something which we have in database, but with similar ID, this object will be easily removed, because delete query verify only primary key. So we move into the query annotation, and inside query annotation, for having more interesting examples, this our query returns single of list of employee. It's part of RxJava. And first of all, we work with cursor, and later on cursor will be mapped to the list of employee, and finally it will be wrapped in a single with Rx Room classes. In pretty similar way, it's working with LiveData. We always start from a cursor. And people who work with Android development for many years and use not only Room library for interaction with database, but also SQLite Open Helper, I think remember the cursor. So it means that under the hood, we have pretty standard way of working with SQLite database, which we always have on Android device. However, with Room, we have pretty beautiful wrapper, which is available for many developers. The next part is, and the last part is database. So for database also will be generated one more file with underscore impl postfix. And if we take a look at implementation of this interface, it's based on our database, which we created, and it has access to our data access objects. It has access to support SQLite Open Helper, and inside this Open Helper, we have many methods which are needed for creating database and for migration. And in addition to it, we have invalidation tracker, and invalidation tracker track all changes in database structure based on query, because together with query we can update structure of our database, and of course it should be tracked. So I think that's all from my side. It was pretty fast overview of main architecture components and main components which used by many developers. And I want to encourage everyone explore tools which you use for every day. First of all, you can do some maybe small optimizations, like you can easily do optimization with set value and post value in a LiveData object. and you can learn how different libraries, how different tools are built, and maybe you can apply this approach in your next solution and make it more efficient. That's all from my side. Thank you.
All right, thank you so much. Right now, we just have one question, so I guess you can answer, and then we can go for a quick break. So the question is, observe forever is tied to which lifecycle owner? That's the question.
Yes, observe forever. Ideally, I recommend don't use it in production when it's possible. We also have method remove observer. So if you just use it, you can just remove it, because lifecycle bound observer, it's observer which is live data based on this observer. So this observer automatically remove live data from the lifecycle of lifecycle owner. However, if you observe forever, you should do it manually.
Okay, excellent. And of course, the Slack channel, I am displaying it on screen. So please continue this conversation on Slack. And thank you so much, Alex.
Thank you.
Right. Yeah. So we are going to go ahead and take a 5-minute break, and then we will learn all about AOSP.